In today's class, we will discuss bilinear transformation or Mobius transformation. As the name itself is suggesting here, it is made up of two linear functions, az plus b linear function in Z, cz plus d linear function in Z. So this function w equal to az plus b divided by cz plus d under the condition ad minus bc not equal to 0 is called bilinear transformation or Mobius transformation, where ABCD are complex constants or real constants. Now, this condition is taken here to satisfy this one more point, that is, if you find dw by dz for this function, it will be denominator into differentiation of the numerator minus numerator into differentiation of the denominator divided by square of the denominator. On simplifying this, you will get AD minus BC by CZ plus D whole square, which is not equal to 0 because AD minus BC is not equal to 0 condition is satisfied here. If this condition is satisfied, what happens here? We have this function with dw by dz is not equal to 0, which claims our bilinear transformation is a conformal transformation. Further, if this function bilinear transformation transforms a function z to itself, then that point z is called fixed point or invariant point. Okay, a point which is mapped to itself under this transformation is called invariant point or fixed point. How do we find them? So if I replace w by z in this, that is, I am saying that z is the input, output is also z. Now if you simplify this one, you will get a quadratic equation, that is multiplying this to the left hand side and taking everything to the left hand side. This reduces to a quadratic equation. By solving it, we can find invariant points or fixed points of the bilinear transformation. Under this heading, bilinear transformation, we are going to see three kinds of problems with respect to your exam. The first kind of problem is this: find or construct the bilinear transformation which maps the points z equal to 1, I minus 1 into w equal to I, 0 and minus I respectively. Here they are saying that if you assume this is your bilinear transformation, if you take z is equal to 1, your w value is I. If you take z is equal to I, your w value is 0. And if you take z equal to minus 1, w value is minus I. This is what it is saying. So now I am supposed to find this w in such a way that, so this condition is satisfied, which means that I am supposed to find A, B, C and D. I need to find these four unknowns. To do that, we are supposed to have this set of equations. Further, this is what I am doing first. I will take z equal to 1 and w equal to I. With that, your transformation becomes I equal to A plus B divided by C plus D with z is equal to 1. So take C plus D to the left hand side and take everything to the right hand side. That becomes this equation number 1. In the same lines, if you take z equal to I and w equal to 0 in this expression, you will get A plus B by Ci plus D is equal to 0. On simplification, it is just A plus B equal to 0. And similarly, if you take z equal to minus 1 and z w equal to minus I, you will get this equation. Now we have got three equations but four unknowns. We know that we can't find the unique solution. What else can be done? Yeah, this is what we are doing now. So now we are going to reduce these three equations into two equations with the three unknowns. How to do that? Here we have got A and B are the two unknowns. Now I will use equation 1 and 3. If I just add these equation 1 and 3, we will get minus id plus id cancels, plus a minus a cancels. I will just end up with 2b minus 2ic equal to 0. That is nothing but b minus ic equal to 0. So now we have got four equations, but not four equation actually. This is one equation and this fourth equation is obtained by equation 1 and 3. And if you observe this equation 2 and equation 4 carefully, so these two are made up of three unknowns A, B and C. So we will write these two equations in the standard form like this: IA plus B plus 0C equal to 0, and here a is missing, so I will write it as 0a plus b minus ic equal to 0. Once if it is done like this, we are going to apply the rule of cross multiplication to proceed further to find these three constants ABC in terms of a single constant k. So how to do that? Please try to understand this. A divided by coefficients of b in the determinant of coefficients of b and coefficients of c are written in the column. That is 1, 1, 0, minus I is written. Minus b divided by I 0, 0, minus I. That is, leaving this column, consider the remaining two columns. Now equal to c divided by, leaving this column, consider these two columns, I 0, 1, 1. And please keep this in the mind. First one goes with positive sign, second one negative sign, third one again positive sign. It goes with alternative signs, plus, minus, plus. And we are equating these three ratios. So these three ratios are equal, means they are supposed to be equated to a same constant. Let me call it as some k. And we know how to evaluate the determinant. So if a1, b1, a2, b2 is there in the determinant, its value is given by a1, b2 minus b1, a2. So that is what we have done here. So by evaluating this, a divided by 1 into minus I minus 0, minus b divided by minus I square minus 0, and equal to c divided by I minus 0, that is equal to k. So which means that each of this ratio is equal to k, which means a is equal to minus ik, b is equal to I square into k, that is minus k, c is equal to ik. So once if you know the value of this ABC, you can substitute in these equations to find the other constant d. So to find d, I can use either equation number 3 or equation number 1. So right now I am using equation number 1, in which I am substituting ABC values to find the value of d in terms of k, and I found d is equal to minus k in this case. So now if I know all these four constants, substitute it back in our bilinear transformation, az plus b by cz plus d, that is equal to minus ikz is your a, and this is your b, and this is your c, and d is minus k. But what you can note, k is common both in numerator and denominator. That will just give us minus iz minus 1 divided by iz minus 1, that is w equal to iz plus 1 divided by minus iz plus 1. So this is the required bilinear transformation. If you want, you can just cross check your answer. This is what you are supposed to do. If you substitute z is equal to 1 back in this, you will get w is equal to I. That is, whatever to form this equation, whatever the z and w values we have found, if you consider those z values, you will get the corresponding values of w to cross check whether your answer is right or not. That's one thing. Okay, so let me just revise this once again. Now what we did, by using the given z and w values, we found these three equations. So we have got three equations with the four unknowns. We are reducing them into two equations with three unknowns. For that, in this case, I have just added equation 1 and 3 to have equation 4, and from 2 and 4 you can find only two equations with the three unknowns ABC. So by the method of cross multiplication, we have expressed ABC everything in terms of k, and we use them back in any of this equation to find the value of d, and we have substituted all these values back in this w to get our required bilinear transformation. But you can note that when you expressed everything in terms of k, and when you substituted here, k is common both in numerator and denominator, and it will be, you are going to end up with an expression which is free from k, which means that I need not to use k anymore. From the next problem onwards, I am not using k in this place, I will just take it as 1. So instead of writing k here, I will just take it as 1. So I will directly write c is equal to I, b is, so a equal to minus I, b equal to minus 1, c is equal to I. That is what I am doing from the next problem. Let me see the next problem. Find the bilinear transformation which maps z equal to 0, minus I, 2i into the points w equal to 5i, infinity, and minus I by 3 respectively. And the question continues, what are the invariant points of the transformation? Here we are supposed to identify the fixed points or the invariant points at the end of the problem. Now, so let me assume w equal to az plus b by cz plus d is the required bilinear transformation. So it's just like the previous problem. If I take z equal to 0 and w equal to 5y, I will get the first equation b minus 5id equal to 0. Second one is z is equal to minus I and w equal to infinity is there. But if I put w equal to infinity directly in this expression, I will get infinity equal to something. So I can't handle this. That's why we know that if w equal to infinity, and infinity value is what? 1 by 0. So which means 1 by w becomes what? 0. So instead of considering w now, I will just take the reciprocal of this. That is 1 by w equal to cz plus d divided by az plus b. Now you substitute the value of z and w. So 1 by w becomes 0 and this becomes c into minus I plus d divided by a into I minus I plus b. And if you simplify this, you will get minus IC plus d equal to 0, because this 1 by w is 0 in this case. By taking this to the right hand side, it is just minus IC plus d equal to 0 is my second equation. Again, by substituting z equal to 2i and w is equal to minus I by 3, I will get my next equation 6ia plus 3b minus 2c plus id equal to 0. Now what I told you people, by using these three equations, you are supposed to identify two equations with the three unknowns. And you can note that you need not to do that step here, because that part is already taken care with this equation 1 and 2. Observe this equation 1 and 2. Equation 1 contains b and d. Equation 2 contains c and d. Totally how many constant unknowns are there here? From these two equations we have got only three unknowns, b, c and d. So what we are doing now, we are rewriting these two equations in the standard form. B plus 0c minus 5id equal to 0, 0b minus 5c plus d equal to 0. So next part is people already know. By using the method of rule of cross multiplication, we will write b divided by leaving this column, consider the determinant of other two columns. 0 minus I, 5i minus 5i 1, which is equal to minus c. It's very important, minus I, minus c divided by 1 0 minus 5i 1, and which is equal to d divided by 1 0 0 minus I. So now on evaluating this, so it is 0 minus plus minus 5 square minus c divided by 1, which is equal to d divided by minus I, and I told you people already it should be equal to just 1. So our answer is b equal to 5i square, minus I square becomes plus 1. So minus c by 1, that gives c is equal to minus 1, d by minus I, that just gives d equal to minus I. Use these three constants or three unknowns in this equation number 3 to find the value of a. In this problem it will be i3. And substitute this i3 back in w, that will give 3iz plus 5 divided by minus z minus I. This is the required bilinear transformation for us. Now the question continues to find the invariant points or the fixed points. For the fixed points, what we are expecting, for the input z we are expecting z is the output, so I should replace w by z now. With that, this gives z is equal to 3iz plus 5 divided by minus z minus I. Take this to the left hand side and simplify that to have this quadratic equation. You can just take the help of the calculator, or you can just calculate it directly by using the formula. To have your answer is, one is z equal to I, other one is z equal to minus 5i. So these two are invariant points or the fixed points of this bilinear transformation. If you want, you can just check this condition. If you put z equal to I here, you can know w is equal to I, and if you put z equal to minus 5i, you will get w is equal to minus 5i. Let me discuss one more problem. In this problem, speciality was one of the value of w was infinity. In the next problem, I have taken one of the value of z is infinity. So what we are supposed to do in that case? So for this one, the same problem happens again. Here infinity will be there, infinity is present means it will be infinity by infinity. We can't handle it. So what we will do now, we will take z common from both numerator and denominator. We will get b by z, d by z, and this z and z cancels. Now substitute w equal to minus 1, and we know 1 by infinity is what? 0. So it becomes a plus 0 by c plus 0. As a result, you will get a plus c equal to 0 as your first equation. Now, so by using the second point, z equal to I and w equal to minus I, this is your equation. By using z equal to 0 and w equal to 1, you have got this equation. But it seems to be like a previous problem, but not exactly. equation 1 and equation 3 goes with 4 different unknowns. This uses A and C, but whereas this uses B and D. So which means we do not have 2 equations with the 3 unknowns. No option. I need to use any of these 2 equations. These 2 equations are these 2 equations. So to get one more equation, so that we will be having 2 equations with the 3 unknowns. Right now what I am doing now, I am adding equation 1 and 2. So to have this equation, it is made up of A, B and D, and I've got one more equation with B and D. So have a look at these 2 equations. These 2 equations goes with 3 unknowns A, B and D. So we will write it in the standard form, and by using the method of rule of cross multiplication, we can have this expression, and by solving these determinants we will get this expression, and with this A becomes I plus 1, B is minus of 1 plus I, D is minus of 1 plus I. Use this value of A, B and D in this equation number 2. So that will give you the value of C, or you can use it in equation number 1 to have the value of C, which is minus of 1 plus I. Now we substitute all this expression back in W, that is 1 plus I z minus of 1 plus I divided by minus of 1 plus I z minus 1 plus I. Okay, note 1 plus I is common here, here also it is common, take it out, and this is what your bilinear transformation. Even in this problem, the question is to find the invariant points or the fixed points. So replace W by Z and you will get a quadratic equation. Solve that quadratic equation to have these 2 roots. Here also you can note minus 1 plus root 2 is used. Your output is also minus 1 plus root 2. If this one is used, your output is once again minus 1 minus root 2. So these 2 are the invariant points or fixed points of this bilinear transformation. So next one, this is the third kind of problem. The first kind of problem is just to find the bilinear transformation. Second kind of problem says after finding the bilinear transformation, find the fixed points or the invariant points. Third kind of problem speaks about finding the images. Now right now in this problem, we are supposed to show that this transformation maps x-axis into z-plane, x-axis of the z-plane into a circle, the mod w equal to 1. Mod w is nothing but what? U square plus v square is equal to 1. We're supposed to show x-axis is mapped to circle mod w equal to 1 and points in the half plane y greater than 0 onto points in the circle mod w less than 1. Now to prove this, first let me solve this expression for z. So that is w is a function of z is given. I need to rewrite in terms of z. Z as a function of w. So cross multiply to this group z expressions and you can note z becomes I times 1 minus w, and here z is taken to the left hand side, it becomes w plus 1 that comes to the denominator. So we have expressed z as a function of w now. Now the question is I want x-axis. X-axis is nothing but y equal to 0. So which means I need to know the value of y first to go further. So for that I will take z is equal to x plus iy and w equal to u plus iv in this. So by using this expression reduces to this form. Here you have got real part is 1 minus u minus iv, u plus 1 plus iv. I want the value of y means I need to separate the real and imaginary parts in this. So multiply and divide by conjugate of the denominator and simplify it to have this expression. Here the value of x is the real part and y value is given by the imaginary part, that is 1 minus u square minus v square divided by 1 plus u whole square plus v square. So now since we know the value of y, so we can consider our first case, that is x-axis in the z-plane should be considered. That is nothing but I have already told you, it is y equal to 0. Substitute the value of y in it, that is y equal to 0 is not the x-axis is nothing but y equal to 0. Substitute in it. So that gives 1 minus u square minus v square divided by 1 plus u whole square plus v square. By cross multiplication, it just gives 1 minus u square minus v square is equal to 0. That says u square plus v square is equal to 1. So that represents equation of the circle mod w equal to 1 in the w plane. Further, I am supposed to consider the values, the points y greater than 0. This speaks about y greater than 0. So this is the line y greater than 0 means so this second and first quadrant, all points from the first and second quadrant we are talking about. So if I substitute the value of y in this, that gives this, in the place of y I am substituting this expression, and cross multiplication gives 1 minus u square minus v square is greater than 0, which means u square plus v square is less than 1. So that says mod w is less than 1, and this mod w less than 1 is nothing but set of all points lying within this circle. Here this y equal to 0 is mapped to this circle mod w equal to 1, and the points, look at this points, set of all points lying in this first and second quadrant are mapped to this, the points within this circle mod w less than 1. So let me discuss one more example. Find the image of mod z less than 1 under the transformation w equal to 1 plus iz divided by 1 minus iz. So now, so solve for z first as usual. So once once if it is solved for z, so consider what? Mod z less than 1. I need not to express it in terms of x and y this time, because the equation is given in terms of z itself. I will consider in the same form. Consider mod z less than 1. What does it represent? It represents set of all points lying within the circle with center at origin and the radius 1 units. This r is 1 in this case. If that is the case, substitute this expression here, and modulus of I or 1 by a becomes 1. So by cross multiplication, this is modulus of w minus 1 less than modulus of w plus 1. Substitute the value of w and separate the real and imaginary part on this. So that gives u minus 1 plus iv, u plus 1 plus iv. So modulus of x plus iy is nothing but what? Square root of x square plus y square. That is what I have considered here. Square root of x square plus v square. Square root of x square plus v square is considered. Squaring on both sides gives this u minus 1 whole square plus v square less than u plus 1 whole square plus v square. V square cancels. U square minus 2u plus 1, u square plus 2u plus 1. U square cancels, plus 1 cancel. We will get minus 2u less than plus 2u. Take minus 2u to the other side, that becomes 0 less than 4u. Or 4u is greater than 0. So 4u greater than 0 implies u greater than 0. What does this u greater than 0 represents? U greater than 0 represents first set of all points from the first and the fourth quadrant. Okay, so set of all points lying within this circle are transformed to the points which are towards the right side of your y-axis. Okay, these are the three kinds of problems which we can see under bilinear transformation. For any doubts, so please come back. So thank you all. Go through the